Okay, Oak Grovers, this is going to be a video to help you factor special cases. And this is from section 8.1.3 in your Algebra Connections book. We're working on section 3, which is factoring with special cases, and we're going to do problems number 23A and 23B. Now the reason 23A and 23B are special cases is because the quadratic, even though it's written in standard form, doesn't look like the normal standard form that we're used to seeing. Normally we see an x squared term, an x term, and a unit term. And in 23a, I have an x squared term and a unit term, but I don't have something x, so I'm missing my x term. In 23b, I have an x squared term and an x term, but I'm missing my units term, so I'm missing one of the pieces in both of these problems. Now to solve these, I do the exact same thing that I've been doing to solve other quadratics in standard form with my generic rectangle and diamond problems. I always start out by putting my tiles, my biggest tiles, in the bottom left-hand corner. And in this case, it's going to be my x squared tiles. I have 9x squared tiles, so I'm going to put those in the bottom left-hand corner. Then I put my unit tiles up here in the upper right-hand corner. In this case, I have -4 unit tiles, so I'm going to put -4 up there. Now the tendency, or maybe the temptation for some of you, is to put 0 in these two boxes. And while that might seem correct, it's not going to be correct because these two boxes have to add up to 0 because there is no x term, but they still have to have a product of -36x squared. And the reason it's -36x squared is because -4 times 9x squared is equal to -36x squared. So in my diamond problem, I'm going to put a -36x squared where the product goes. And I've already put that 0 because I have to have a sum of 0x when I add these two boxes up. Now 36 is a perfect square, so I know that 6x times -6x, if I multiply those together, I get -36x squared. But if I add 6x and -6x, I get 0. So these are the numbers I have to put into these rectangles, 6x and -6x. Now if I look at my bottom row of this problem, I have 6x here and 9x squared there. 6 and 9 have a common factor of 3. X squared and x have a common factor of x. So I'm going to put a 3x outside this box right there, and that means I factored out a 3x from this row. Now if this dimension's 3x, and my area is 9x squared, that means that this dimension has to be 3x. And if this length is 3x and my area is -6x, that means that this dimension has to be -2. Let's go down here and figure out this length over here, this side. Well, I know that this length has to be 3x and my area is 6x, so this length has to be +2. So now if I want to write that as a product and a sum, the sum is 9x squared minus 4 is equal to 3x plus 2 times 3x minus 2. And I get the 3x plus 2 because that's that dimension of the big generic rectangle, and 3x minus 2 because that's this dimension of the big generic rectangle. Now this problem is one that's going to come back a little bit later when we talk about the difference of squares. 9x squared is a perfect square, and so is 4. So I'm really subtracting two perfect squares, and I have a difference of squares here. We will talk about that in a later video, probably in a day or two. Let's go on to number B, or letter B, excuse me. So for this problem, I know that my x squared is 12x squared. So let's go ahead and put that in the bottom left-hand corner. And then I don't have any unit terms, so I'm going to put 0 up there. Well, the product of these two boxes is 0 because 0 times anything is 0. So I'm going to put in the product box, or product part of my generic rectangle, a 0. But these two boxes, while they have to have a product of 0, because it has the same product as this one, or these two boxes, they have to have a sum of -16x. So I'm going to put a -16x down in the bottom part of my generic rectangle. So I have to have a product of 0. In order to get a product of 0, one of the numbers has to be 0. And if I have a sum of -16x and one of my add-ins is 0, the other one will have to be -16x. So I'm going to put a -16x in that box, I'll put my 0 up in that box, and then let's factor out the bottom row. I have 12x squared, negative 16x. They both have an x in common, and 12 and 16 have a common factor of 4. So that dimension is going to be 4x. Now if this length is 4x and my area is 12x squared, this length has to be 3x. If this length is 4x and my area is negative 16x, this length will have to be negative 4. If this length is 3x, but my area is 0, that means that this length has to be 0. So to write this problem, 12x squared minus 16x, as a product and a sum, I'm going to write it as 4x times 3x minus 4. Hopefully that helps with some of your special cases. Make sure you always put your x units, or your units in the upper right hand corner and your x squareds in the bottom left hand corner. If you do that, everything else will fall into place.